something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Hello everyone, welcome to Unacademy GATE Conqueror YouTube channel. Good evening guys. Please let me know whether both audio and video are clear or not. Please confirm guys. Please confirm the audio and video. Good evening Ram. Good evening Saloni. Good evening Navyasri. Yeah, good evening Kartikeya. Yeah, please confirm guys. Is audio and video are clear or not? Vishwa. Hi Vishwa. Good evening Drupad Saha. Please confirm guys whether the audio and video are clear or not. Good evening Venkat. Please confirm once. Share the session guys. Share the session. Good evening Suraj. Okay, it is audible right? Okay, fine. So in this session I'm going to explain the concept of linear algebra in a complete different way. Altogether this session is going to be the complete different approach for linear algebra. Here we are going to start from the basics and we are going to see all the topics and all the subtopics very clearly, so that we are going to get a complete clear-cut idea on linear algebra, right? Before going to start the session, let me tell you about myself. I am Babu Ande, having 5 years of teaching experience in GATE, and my MTech is in power systems. Before joining my MTech itself, I started teaching maths and aptitude. After that, I took controls as well. You can use my code HARIMATH to get 10% off on Unacademy Plus subscription. Yeah, these are the two platforms that are there in Unacademy, Plus and Iconic. In Plus, we are going to have live classes, doubt clearing sessions, crash course, weekly test for both English and Hindi as well. In Iconic subscription, we are going to have all the features that are there in Plus. Along with that, we are going to have some personal coach and study materials, study planners and all. Coming to the next one, these are the pricing plans for Plus course for 12 months, 18 months and for 24 months. Okay, you can use my code HARIMATH to get 10% off here. to get 10% off, and you can make the payment in EMIs also. Coming to the next one, this is iconic pricing plans for 12 months, 18 months and 24 months. Okay, here also you can use the code HariMath to get 10% off. To get 10% off, right? Next, these are the Unacademy Ask a Doubt, where you can ask any doubts at any time. You can ask unlimited doubts also, where you are going to get the high quality video solutions in English and Hindi as well. Okay, and you are going to get assistance for your homework also. Coming to the next one, these are the new batches for GATE 2022 and 2023, for ESE 2022 and 2023, for both electrical and ECE as well. For electrical and ECE as well. Coming to the next one, the special classes. What is meant by special classes? These are the live interactive sessions that are available in Unacademy app for free. There are some special features are there for this one, like polls. That means the educator is going to ask the questions in the form of polls, where you need to respond for the better understanding. Okay. The one more good feature is raise a hand. Raise a hand. That means you can talk to the educator directly in the live itself by using the raise a hand option. Right. Next one, never miss a class. If you click follow for your favorite educator in Unacademy app, you are going to get the notifications all the time whenever that educator is coming to live, so that you are never going to miss this class. Next one is you can download lecture notes also. Of course, you can watch at any time and anywhere. Right. Coming to the next one, Bugs Bounty. This is nothing but the learners are going to get rewards if they find any inappropriate content in Unacademy, right? Yes. Now, let us start the session. Let us start the session. Let us start the session. Yeah, good evening, Barney. Yeah. Good evening, Abhi. Good evening, what? Yes. Please share the session, guys. Please share the session. This session is going to be the very useful topic for complete linear algebra. Our approach is going to be totally different, right? Yeah. Before going to see the topics and subtopics, let me ask a small question. Here I am going to give you two set of equations and try to give me the answer. This, if you are able to observe the concept behind this question, whatever I'm going to ask, you can able to understand complete linear algebra very easily. We are going to solve a beautiful conceptual question also based on the same thing. Just I'm going to give very small equations only. Just try to solve and tell me the answer. That's it. Okay. The equations are x plus y is equals to 11 and 2x plus 3y is equals to 28. Okay, these are my favorite equations, I can say. This is the one set of equation. And coming to the next one, x plus y is equals to 11 and y is equals to 6. Try to solve these two equations, guys, and tell me the answer. I need the value of x here and also y here. Similarly, here also I need the value of x and I need the value of y. Simple. It's a very simple question, but we are going to see a great concept behind this answer, right? So share your answer, guys. Share your answer. Amit, good evening, Amit. Solve these equations and tell me the answer. What is going to be the value of x and y? That is my question. A very simple question, but we are going to solve a beautiful question based on this concept. What are the values of x and y? That is my simple question. Come on, guys. A very beautiful concept is behind this one. X plus y is equals to 11 and 2x plus 3y is equals to 28. This is one set of equations. And second one is x plus y is equals to 11 and y equals to 6. What is the value of x and y? That is my question. Yes, x is equals to 5, y is equals to 6. Last year, correct. X equals to 5, y is equals to 6, correct. Yes, come on, guys. 5 and 6, 5 and 6, 5 and 6, 5 and 6. Yes, correct. Now my question is, this 5 and 6 are the values for this equation or for this equation or for the both equation. That is what my question. So let me solve these equations on my own. Okay. So let me take the first equation here and try to multiply the first equation with 2. Okay. So that what I am going to get here, I am going to get 2x plus 2y is equals to 22. Okay, I have taken this first equation and I have multiplied with 2 simply, right? Now I am going to take this for second equation, which is 2x plus 3y is equals to 28, and I am going to subtract this one, so that I am going to get 6. I am going to get 6 here. So let me take one more equation, which is x plus y is equals to 11. X plus y is equals to 11, right? X plus y is equals to 11 and y is equals to 16. These are the equations I got after doing some manipulation. See here, what I have done? I have done some manipulation. This manipulation is having some meaning. Okay, this manipulation is having some meaning. Okay, so finally again I got x plus y is equals to 11 and y is equals to 16. If you try to observe, these two equations also same. X plus y is equals to 11 and y is equals to 6. Okay, anyhow y is 6 only directly, x value is 5. Okay, so here also x is 5, y is 6. Now my question is these values of x is equals to 5 and y is equals to 6 are the answers for this equation, or these are the answers for this equation, or for the both equations? This is my question. I hope my question is clear for everyone. This x is equals to 5, y is equals to 6 are the solution for this first set of equations, or for second set of equations, or for the both the set of equations? Tell me guys. I hope my question is clear to everyone. This question is having the concept in it. Okay. Tell me guys. Yes, right? My question is clear, right, Ram? Now tell me then. Tell me. These solutions are for first one, or for second one, or for both? Ram, both, right? Both. But actually if you try to see, this equation is again converted into this equation only. X plus y is equals to 11 and y is equals to 6. If you try to see, if you try to solve from here, I am going to get this one, right? But how I can say this x is equals to 5 and y is equals to 6 is solution for this one also? Yes, that is correct. For both, the x is equals to 5, y is equals to 6 are going to be solutions for both. But if you try to see from here, x plus y is equals to 11, y is equals to 6, that is what we got here, right? That is what we got. If you try to see, some difference is there for these two. Okay, yes. What you are saying is correct. This is solution for both the equations, but I am asking the reason why. Why the same solution is satisfying both the set of equations? Right? Both the set of equations. Actually, I got this system by making some kind of manipulations, right? See here, I got this system by making some kind of manipulations, but still they both are having same solution. Why? This is what my question, and I am going to give the clarity by taking one example, right? Before that, let's see what are the topics that are there in linear algebra, topics and subtopics, right? These are the main 3 topics we can say in linear algebra: matrix algebra, system of linear equations, and eigenvalues and eigenvectors. As we have seen in the yesterday's session, that the main objective of this complete linear algebra is to find solution, right? Is to find the solution for system of linear equations, right? Actually, there are so many methods in order to find the solution for the system of linear equations, right? So let me take the first method. To find the solution for system of linear equations. Okay, let me take the first solution method, we can say the first solution method. The equations are going to be same, right? Here x plus y is equals to 11 and 2x plus 3y is equals to 28. 2x plus 3y equal to 28, right? So the same equations, let me write in matrix form. So if I try to write in matrix form, this one we can represent in Ax is equals to b. Okay, here the matrix A is belongs to coefficient matrix, this one is belongs to constant matrix, and this one is variable, right? Whatever the manipulations that we are going to do on these equations, the x and y will remain same, maximum it may vanish, but the constants are going to be changed all the time. So let me write all those constants and coefficients in one matrix, and let me call this one as augmented matrix. Okay, so let me write this one as 1 1 11 and 2 3 28. 2, 3, 28. Okay, let me do some manipulation here by taking R2 goes to R2 minus 2R1, R2 minus 2R1. That is what we have done previously also. Okay, so that what we are going to get here, we are going to get 1, 1, 11 here, and similarly we are going to get this one as 0, and this one as 1, and this one as 6, this one as 6, right? Right. Actually, this solution method we have known since our childhood. Immediately after seeing this equation, we are going to apply the same process all the time. Okay, is this method having any name for it? Why we are trying to make this element as 0? Is this process is having any name? This is the one of the famous solution method. Yes, so I need to know what is the method that we are applying here. We know this kind of solving technique since our childhood, but what is this type of method? And what we are trying to do in this one? I am asking what we are trying to do in this one. Okay, this method is having a name for it. Thus that name is Gauss elimination method. This method having a name which is Gauss elimination method. That one is first method. What we are trying to do here in this method, we are trying to take all the constants and coefficients, and we are trying to perform some manipulations, some kind of operations, and we are trying to convert this element as 0. That means in matrix terminology, we are trying to convert this one as some upper triangular matrix, right? So Gauss elimination method is a solution technique in linear algebra which is used to convert the matrix into upper triangular matrix, so that we are going to get one variable value directly. From that one we can able to calculate another variable, and so on. Okay, this is what we know. This method we know since our childhood. That is called as Gauss elimination method. Yes, we know, but why I am trying to explain means because of this one. Try to solve this question, then you can understand. In Gauss elimination method, for solving system of linear algebraic equations, the triangulation leads to. Yes, Amit, Gauss is correct. Suraj, elimination method is correct. Drupad Saha, elimination method is correct. Yes. Now try to answer this question. Now this question will become so easy after knowing the topic, right? Yes. In Gauss elimination method, for solving system of linear equations, the triangulation leads to. Yes, Drupad Saha, C. Saloni, C is correct. Krishnakant, C is correct. Yes. Suraj Padi, upper triangular matrix. Option C is correct. Rohit John, C is correct. Yes. Upper triangle matrix. C. This is what the exact purpose of learning concept behind each and every question. If you try to see whatever the process that we have known already, it is having some inherent logic and inherent concept in it. If you properly understand, then you can get almost every concept behind each and every topic. Okay, so in the same way, let us try to solve one more beautiful conceptual question, right? See here, this is a very important conceptual question given in one of the competitive exam previously. Okay, so try to answer this question. Venkat, upper triangular, correct. Kartikeya, C, correct. Narendra, good evening. Vishwa, C is correct. Try to solve this question, guys. This question, if you are able to solve this question, fine, you can solve this question, I know. Okay, not only solving these questions, if you know the concept behind this question, then it's great. You can able to understand, you know already linear algebra, I can say. You know the complete linear algebra, I can say. Yeah. I am telling the answer, just you give me the reason for it. The system of equations ax plus by plus cz is equals to 0, and the next one bx plus cy plus az is equals to 0, and third one cx plus ay plus bz is equals to 0. Okay, these are having unique solution as per the question, right? Now he is asking what is the solution for this set of equation? A plus b into x plus b plus c into y plus c plus a into z is equals to 0. Okay, this is first equation. And coming to the next, which is b plus c into x plus c plus a into y plus a plus b into z is equals to 0. Third one, c plus a into x plus b plus a into y plus b plus c into z is equals to 0. Okay, now we know this system is having already unique solution. Then what about this what about the solution for this system? Okay, directly I am giving the answer. Option is A. Option is A. But justify. How? Yes. Navyasri, answer A is correct. Kanasujini, unique solution is right answer. But my question is how? How by using this system knowledge, how we can say this system is having unique solution or not? Just tell me, guys. If you are able to understand this concept behind this answer, then you know complete linear algebra. Come on, guys. Any replies? What is the concept behind this one? What is the concept behind minus x2 plus x3 is equals to 1 and x1 minus x2 is equals to 0 and 2x1 plus x2 minus x3 is equals to 2 right? This is a system that I have taken already. Now I am going to form one more system. By adding these two equations. Tell me now, add these two equations and tell me what is going to be the resultant. Resultant is going to be x1 2x1, right, minus 2x2 plus x3 is equals to 1, 0 plus 1, right? Similarly, add these two. What we are going to get? We are going to get 3x1, okay, x2 will get cancelled, and similarly we are going to get minus x3 is equals to 2. Okay, similarly add these two equations and tell me this is going to become 3x1 plus x2 will go and x3 also will go. This is equals to 2 plus 1 3, right? Now I have formed a new set of equations from the given set of equations, right? What I have did some manipulations on the given system. And I have formed a new system. Now these two are going to have some kind of relation with them. Now I will tell you the answers x1, x2, x3 are equal to 1. See, it will be satisfied. 1 minus 1 0 gone, 1 minus 1 0, this one 2, 1 minus 1 gone, 2. Okay, so 1 1 1 is the solution for this set of equation. Now the system which is formed by making some manipulations on this, try to see this one. This one is, if you take this 1 1 1 as solution for this one, okay, just check whether it is satisfying or not. 2 gone, 1 is equals to 1. Similarly 3 minus 2 2, and 3 into 1 is equals to 3. That means this system is formed by making some manipulations on this system. Okay, so this is having solution as 1 1 1 and this is also having solution as 1 1 1. Now are you able to correlate anything between these two? Now you can. Now I hope it is clear. I think. Now it is clear. I think. Yes. Actually, some beautiful theorem is there based on this one. That is going to be the important for entire linear algebra. Linear algebra. That means if a system is formed by making some linear operations on a other system, then we can say both the systems are equivalent. And they are going to have the same solution. That means if you know the solution for this equation, then you need not to know about the solution of this equation. Okay, because they are somehow equivalent. You can say they are equivalent systems. What is the statement here? Try to observe clearly. If a system is formed by making some kind of linear operations on other system, then we can say both the systems are equivalent. And they are going to have the same solution. Based on the same concept only, here we got the same the same answer for the both the equations. I hope you can able to connect with these two. This system is different. This system is different, but this system is formed by making some kind of manipulations on that. That means some kind of elementary row operations. These manipulations are nothing but elementary row operations. Okay, so these systems are equivalent to each other and they are going to have the same solution. They are going to have the same solution. That is the concept behind the solution of linear equations. I hope it is clear for everyone, I think. I hope it is clear for everyone, I think. Yes. I hope it is clear for everyone. Right? This is the concept behind everything. That's why even we are taking some kind of linear operations and all, we are taking the ultimate end of the solution as solution for all the set of equations. All the set of equations which are formed after making so many linear operations. Right? I hope it is clear for everyone. Yes. You understood, guys? Yes. Yes. Using determinant concept also we can able to solve this question, correct? Yes. Someone replied that using determinant concept also we can solve. But that is going to be very tedious. You can try. You can try and you can tell me which is easy method. You can try by using determinant and all, and you can try by using this logic. By using this logic, then you will come to know. Which is the most easiest way. If you understand the concept, then it's very easy. Right? I hope it is clear for everyone. If anyone are having any doubt, please ask me. If you are having any doubts on this. If you are having any doubts, please ask me. Yes, right? It is clear for everyone. Still any doubt you can ask. Yes, of course, this problem can be solved by using the determinant concept also. But that is going to be very tedious. Okay, so let me move on to the next one. Actually, we are trying to see the solution methods, right? We are trying to see the solution methods. In the as a part of that, we have seen the first solution method, which is nothing but Gauss elimination method. Let me tell you the second one, which is Cramer's rule. We know this one very well, right? By using Cramer's rule also, by using Cramer's method also, we can say we can able to find the solution for system of linear equations or not. Yes. Okay. So if there are three variables, then the formula is going to be x is equals to delta 1 by delta and delta 2 by delta, and z is going to be delta 3 by delta. Okay, here the delta represents the determinant. Of coefficient matrix, and delta 1, delta 2, delta 3 are formed by making some kind of shuffling of the constant matrix in the coefficient matrix and all. Okay, so this is the second one. Coming to the third one, matrix inverse method. Third one is going to be the matrix inverse method. What is this method? In this method, we know the matrix form we are going to represent in the form of Ax is equals to B. And if we want this unknown matrix X, then we are going to write this X as A inverse into B. Right? So what is A inverse here? A inverse is going to be adjoint A by det A into B. Okay? Again, adjoint A means cofactor matrix transpose divided by det A into B. From where cofactor will come? Cofactor will come from minor. If you don't know any of these words, no need to worry. Just I am going unique solution or no solution or infinite solutions. Okay, these are the three methods that we are having to find the solution of a linear equation. If you try to see which is the good method to apply, or which method is giving more information, means obviously we can say the rank method. Why means in the rank method we can say whether the system is having unique solution or no solution or infinite solution. But whereas in case of Cramer's rule and all, if suppose determinant value is equals to 0, then what we can do? Similarly here also, if determinant is equals to 0, then how we are going to find inverse? How we are going to find inverse, right? It's difficult, isn't it or not, right? So, but whereas even in case of rank method, even determinant equals to 0 means we are going to, the rank value will change. Nothing is going to happen much, right? So among these three methods, which is the most better and which is giving more information about the solution of definition, solution of equation means linear equation means, that is rank method. That is rank method. Is it clear or not? That's why in finding the solution maximum times we are going to use rank method only. We are going to use the rank method only. Okay, but I am using so many words like determinant, A inverse, adjoint, det A, cofactor, minor and all. So from where all these concepts are going to come? From where I am going to get all these terms and all the knowledge? Okay, I am going to get this knowledge from the topic called matrix algebra. We are going to get these all terms from the topic called matrix algebra, right? We are going to get the concept of determinant and inverse and rank. So we are going to learn these topics from matrix algebra, and we will try to find the solution of system of linear equations by using these basics. Okay, that is what the relationship between linear system of finding solution of linear equations and matrix algebra. Is it clear, guys? Is it clear? Yeah, Drupad. Yeah. In rank method, we are going to find rank of A, rank of AB. We are going to see what is meant by rank, what is meant by A and AB and all. Okay. And by using rank of A and rank of AB, we can say whether the system is having unique solution or no solution or infinite solution. Okay. We can give the clear-cut idea about the solution. But whereas in these methods, that kind of clear-cut idea is not going to be there. Okay. That's why majority of the times we are going to use rank method only. We are going to use the rank method only, right? I hope it is clear. I hope it is clear, Drupad. Come on, guys. Any doubts on this? Yes, perfect. Right? Now, there are another methods also like LU decomposition, Gauss seidel, Gauss elimination and all. But we are going to see these things whenever these topics are coming. Okay, so these all topics are to find the solution for system of linear equation only. So but among all those, the rank method is going to be the best suitable method, and we are going to apply this method only. Okay, so now we are going to start matrix algebra. Okay, from the matrix algebra is our objective is to know what is meant by determinant, what is meant by rank, what is meant by A inverse, what is meant by cofactor, minor and all. Okay, we are going to get all the knowledge from that one. Okay, from that one. See here, now we are going to start matrix algebra. Right, which is the first part of linear algebra, because all the basics related to the solving techniques of linear equations are there in matrix algebra. Okay, so let me start with the definition of matrix here. A very simple one, we all of us know. Matrix, a rectangular array of mn elements, we can say. Okay, a rectangular array of mn elements. Mn elements means m into n is a product. Mn elements, right? These elements may be numbers, may be characteristics like A, B, C, D and all characters. Okay, and they may be expressions also. Okay, again these numbers may be real or complex. So if the entries or if the elements that are there in matrix are complex, then we are going to have some topic called complex matrices and all, and we are going to see that one also. It is simply a rectangular array of mn elements. Okay, that elements may be numbers or characters or expressions, anything. Okay, how we are going to represent matrix? We are going to represent the matrix as Aij and m by n. Okay, what is m and n here? Here this is related to rows and this is related to columns. And this decides the position of element. This I comma j will decides the position of element. Okay, why we have to understand this one? Means because in so many problems the question will be framed based on the index. That means Ij values, based on the Ij values, right? Ij values. Now let us solve a simple and a very small question. See here, an n by n array is given here. V is defined as follows. Okay, so the matrix is defining like this: E of Ij is equals to I minus j for all 1 less than or is equals to I comma j less than or equals to 1. Okay, that means here the I comma j values are varying between 1 to n, right? So now what you need, then the sum of all the elements in the array, here nowhere it is used that it is matrix, because that is what meant by array, right? An array of n by n numbers, okay, is nothing but matrix, right? So matrix is defined like this: V of I comma j is equals to I minus j, and what we need here, we need the sum of all the elements in the matrix, right? So let us consider if n is equals to 2. Then we are going to have 2 by 2 matrix. In that, the first element is going to be A11, second one A12, third one A21, fourth one A22, right? So now here this value is I and this value is j. Similarly, this value is I, this value is j. Ij. Okay. So now try to find the matrix V here. V of Ij is equals to the first one 1 minus 1, 0. The second one 1 minus 2, minus 1. The third one 2 minus 1, 1. Fourth one 0. Okay. So this is as an example whatever I have taken, right? So if you take this one, what is going to be the answer here? Simple question, very simple question, right? Come on guys, give me the answer. Give me the answer for this one. Yes. Even we can take anything here. As a example, as a particular case, I have taken n is equals to 2. But whatever the value of n you take, we are going to get answer 0 only, because this V of I comma j is equals to I minus j is a special kind of matrix. Can anyone say this? Trupad Saha, 0 is correct. Saloni, 0 is correct. That's fine. Can anyone say V of I comma j equals to I minus j is going to form which kind of matrix? This matrix is having some special name. Yeah. Anyhow, at the time of seeing types of matrices and all, we are going to see, but it's fine. Okay, so this is a skew symmetric matrix, okay, where you are going to have the off diagonal elements are going to be the opposite sign of the other elements. Okay, so is it clear, guys? Is it clear? Yes. Okay guys, now this is clear, right? So let us move on to the next topic, which is matrix multiplication. We are going to see some important questions on this. Okay, so let me take a matrix A. Which is a matrix which is of order m by n. Right? Let me take one more matrix B, which is of order P by Q, right? So if I want to multiply these two matrices A, B, right? So here A is a matrix of order m by n and B is of order PQ, this one since our childhood. So let me take two matrices as an example. 1, 2, 3, 4. Okay, this is 2 by 2. And let me take one more one. Okay, this is rows and columns. So as per this statement, the number of columns in first matrix equals to the number of rows. Okay, so based on that, if I take this one, this is having 2 rows and 1 column, right? So we are going to get the resultant matrix as 2 by 1 matrix. We are going to get the resultant matrix as 2 by 1 matrix, right? How we are going to do? Like this, right? Rows, columns, right? If I try to do in that way, 1 into 1 plus 2 into 2 is going to be 1 plus 4, 5, and similarly 3 plus 8 is going to be some 11 we are going to get. Okay, actually our point of interest is not to find the multiplication, but our point of interest is how many multiplications we have used and how many additions we have used in order to get this result C. Okay, in order to get this result C. That is what the questions will come from exactly. Okay, see this question. If a matrix A is of order m by n and B is a matrix of order n by p, and in order to take the multiplication for these two matrices A, B, okay, so the number of multiplication operations and addition operations needed to calculate AB. That is what the question here. We know how to do the matrix multiplication, but here the point of interest is how many number of multiplications and additions are going to be involved in finding matrix AB, right? The process of doing is important for everything. Okay, tell me the answer, guys. Tell me the answer. Good evening, Vikas. Good evening. Tell me the answer, guys. How many number of multiplications and additions are required? How many number of multiplications or additions are required in order to find AB? That is the question here. That is the question. How to solve this one? So let me take a simple example, a row matrix and a column matrix. Okay, so here 1, 2, 3, 4, 5, 6. Okay, if I try to take multiplication of these two matrices, what we are going to get here? Just try to do 1 into 4, right? 1 into 4 plus 2 into 5, right? 2 into 5 plus 3 into 6. Okay, overall how many multiplications were used and how many additions were used here? 1, 2, 3, right? Total 3 multiplications are used in order to get this one, 4 plus 10 plus 18. Okay, 4 plus 10 plus 18, right? See here, how many additions were used? 2. How many multiplications were used? 3. How many multiplications were used? 3, right? So this is for one element. In order to get the one element, we are having 3 multiplications and 2 additions, right? In the same case, for m by n and n by p matrix, for the multiplication of these two matrices, how many multiplications and additions are required? That is the question. Any answer, guys? Any answer? Yes, Saloni C, correct. Vikas, C is correct. Drupad, C is correct. Kunal, C is correct. Okay, if you try to see here, if I take product for these two matrices, A m by n and B n by p, okay, so how many elements are there in the resultant matrix? C is the resultant matrix with order m by p. That means it is going to have total mp elements, right? Total mp elements. Okay, mp elements. In order to get one element, how many multiplications are required? See here, this is having 3 elements. Otherwise, let me write like this. This is 1 by 3 and this is 3 by 1. Right? 3 by 1. So in order to get the one element, how many multiplications are used? 3, because here the common one is 3. Okay, in this 2 the common one is n, right? So in order to get one multiplication or in order to get one element, we are going to use n multiplications. For similarly, for MP elements we are going to get MPN multiplications, MPN multiplications, right? Similarly, the additions. If there are n multiplications, there will be n minus 1. There will be n minus 1 additions required. There will be n minus 1 additions required. Right? So here the how to find multiplication is not going to be that much weightage, but the process of doing multiplication and how many number of multiplications in individually and additions are required in order to find the multiplication is important. Right? Yes, I hope this concept is clear for everyone. This is very easy only. Right? We can say very easily. Yeah. So let's see one more problem based on this matrix multiplication only. See here, what is the minimum number of multiplications involved in computing the matrix product? PQR, where P is going to have 4 rows and 2 columns, and Q is going to have 2 rows, 4 columns, and R is going to have 4 rows and 1 columns. Okay, in which one the number of multiplications are involved are going to be minimum? In which case the number of multiplications are going to be minimum? We have seen how to find the number of multiplications. If A is a matrix of order m by n and B is a matrix of order n by p, okay, then the number of multiplications are going to be m into n into p. That is what we have seen. But here what it is asking? Here it is asking minimum number of multiplications. Minimum number of multiplications we need to find in order to find this product PQR. Tell me the answer, guys. Tell me the answer. Or how to proceed? How to proceed means actually finding multiplications for 2 matrices can be done very easily, A into B. But finding multiplication for 3 matrices can be done in 2 different ways. That means first of all we can take product for PQ and after that we can multiply with R. Similarly we can take multiplication of Q and R. After that we can multiply with P. So these are the 2 options. And they are both are going to be equal. This is what we can say, like one of the important property in matrix multiplication. Okay, now first of all try to find the number of multiplications required for PQ. Okay, and again multiply the result with R and find the number of multiplications here, and similarly find the number of multiplications required for QR. Okay, again one matrix will come, and multiply this matrix with P and tell me how many number of multiplications are required to find the final product. Tell me the answer, guys. Tell me the answer. Yes. Yeah, let us see. Very good. So many are giving replies. See here, this one. In order to find PQ, how many multiplications are required? 4 into 2. In order to find this one, how many multiplications are required? 4 into 2, 8, right? 8 into 4, 32. We are going to get here, right? Again, if you try to see, the resultant matrix is going to be 4 by 4 here. Again, this one is going to be 4 by 1. Okay, here we are going to get 4 into 4, 16. Okay, here we are going to get total 48, right? Coming to this case, QR means we are going to have 2 into 4, 8. Okay, we are going to get 8 multiplications here. Similarly, the resultant matrix is going to have order 2 by 1. This one 4 by 2, right? Now we are going to get 4 into 2, 8 here. Total 16. Which is the minimum multiplications case? Which is the minimum case? 16, right? 16 is the minimum case, right? 8 plus 8 is 16. Yes, the number of multiplications to obtain PQR. Perfect. Is it clear, guys? Is it clear? This is also related to matrix multiplication only, we can say. Matrix multiplication only. By using this property, we should know this property in order to solve this question. Otherwise, we cannot solve this question. Impossible. Right? Perfect. 2 into 4 into 1 plus 4 into 2 into 1, 16. Yeah. Can I move to the next question, guys? See here, the matrices cos theta minus sin theta cos theta, and A0, B0 are commutative under multiplication. Okay, what is meant by commutative property? What is meant by commute? What is meant by commute? We should know commutative property of matrix multiplications, right? We are going to have the products, right? AB and BA also. When actually it's very difficult to say AB, BA will exist all the time because of their order of the matrix. For suppose if they exist, AB and BA, and if they are getting equal, then we can say the matrix multiplication is following commutative property. Right? So try to find AB here, and try to find BA also. Try to equate AB is equals to BA, and tell me under which conditions AB is becoming BA. That is what the answer for the question. Yes, commutative law is correct. Try to solve this one, guys. It's a very easy one only, you can say. These are the very basics, very small basics. That's why we are covering with little bit faster rate, so that we can enter into the very good topics of matrix algebra very soon. Yeah, so let me try here. What is AB here? Try to take AB. Cos theta minus sin theta, cos theta. Okay, this is what A. And coming to B is going to be A0, 0B. Okay, let me multiply this one, so that what we are going to get here, we are going to get A cos theta, and second one is going to be 0. Next one minus B sin theta. Okay, again this one and this one. Okay, A sin theta here and B cos theta here. Similarly BA, right? A0, 0B, and this one is going to be cos theta minus sin theta and cos theta. Okay, again same row column. How much is going to be? A cos theta. Okay, and similarly the second one is going to be A cos theta. Similarly this one B sin theta, and this one last one B cos theta. Okay, yeah. So when this one is going to be equal, if you try to see the condition here, A cos theta is same. Okay, and this one A sin theta should be equals to B sin theta. Okay, that means what is the meaning here? A should be equals to B. And again at the same time, if you try to equate these two elements, then we are going to get the condition called theta is equals to n pi. Right? This is a very simple problem, we can say AB is equals to BA, right? So based on the matrix commutative property, we can able to solve this one, and we can say the answer is going to be A. Here, right? So this is what about matrix commutative property. Previously we have seen associative property, right? I hope this is clear, I think, right? Is it clear, guys? Yes. On a whole, in this session we have given the introduction to the topic linear algebra, and we have seen what are the different solution methods and all. Okay, and we have started matrix algebra, and we have seen the basic definition of matrix, and we have solved a very beautiful conceptual questions also. In tomorrow's session we are going to start the matrix, we are going to continue the matrix algebra itself, right? So thank you so much guys for watching. Please like the session, share the session, subscribe the session. Okay, next K.N. Rao sir session is going to be there, so please join there. Okay, thank you.